Venus, the inner planet, also known as Earth's evil sister. Sister because it is almost the same size and mass as Earth. Evil because it is highly toxic and very, very hot. But Venus's real claim to fame is its transit. At intervals of more than a century, Venus is seen as a black dot against the bright sun. A predictable event that happens in pairs 8 years apart. The transit of Venus. The first transit of Venus ever seen by humans was in 1639. Ever since, its importance has only increased. This is the event that enabled us to measure the distance between the Earth and the Sun and the expanse of the solar system. Let's prepare for the transit of Venus 2012 with some action on the field. That's the Sun. And this is Earth, revolving around the Sun in its orbit. Watch how the child playing Earth is moving slowly and holding the globe denoting the Earth at a fixed level in line with the Sun. And this is Venus, the girl carrying another ball. She starts revolving in her orbit, but observe her speed. It's faster than Earth. Notice how she lifts the ball over her head and then starts lowering it, bringing it to her knee level. This is to denote the angle of Venus's orbit with regard to Earth's orbit. They are inclined, and that is why Venus passes Earth either from above or below. Practice this movement and coordinate it, because once every 121 years or so, the two planets line up. They line up with the Sun, and that's when the transit happens.
ये एक्टिविटी करके मुझे ये पता चला कि वीनस बार बार इसलिए नहीं दिखता क्योंकि या तो वो ऊपर से निकल जाता है या तो नीचे से, जिसकी वजह से वो क्रॉस नहीं करता.
But why does Venus go from above or below the Earth? Time to make a simple model. Time to understand the orbits of Venus and Earth and their placement. Here's what we need to make the model. Stiff white card paper, 2 round plates, one big, the other small. An easy way of drawing 2 circles. A cutter to cut the card paper, a pair of scissors, a long ruler, and a packet of colored bindis. Here's how to make it. Place the larger plate on the card sheet and draw its outline. Now place the smaller one in the exact center and draw its outline. What you now have are 2 circles drawn like this. Cut out the larger circle. You may prefer to use the cutter. Now take your ruler and draw 2 slashes on either side of the diameter like this. Start cutting the inner circle from one slash to the other so that the 2 circles still remained joined. Take the bindis and start sticking them. The red big one in the center, yellow dots along the inner circle and a different color along the outer one. Let's understand what we've just made. This is a model to understand the transit of Venus.
हमने एक प्लेट का इस्तेमाल करके एक आउटर सर्कल काटा.
Outer circle to show the Earth's orbit around the Sun. The blue dots are of course Earth, marking its various positions.
और उसके बाद हमने एक इनर सर्कल भी काटा.
The orbit of Venus inclined to Earth's orbit at an angle of 3.5 degrees.
ताकि हम दिखा सकें कि जो वीनस का ऑर्बिट है वो अर्थ के ऑर्बिट को इंक्लाइन करे.
The simple cardboard model shows the daytime astronomers how Venus passes from above the Earth or goes from below.
इससे या तो वीनस ऊपर से चला जाता है या तो वह नीचे से चला जाता है.
But of course, it is not always so. Once in more than 100 years or so, it lines up with the Earth, and that is the time for the transit of Venus.
June 2012. 6 June. 6 June. 6 June.
हाँ, जब 6 जून को ट्रांसिट होगा तब मैं उसे जरूर देखूंगी. मैं बहुत एक्साइटेड होंगी.
Things needed to set up the transit of Venus in the playground: a stand, a 2-scale image of the transit of Venus, a marble of 1.21 cm diameter, the Nano Venus tied to a thread. The children here have used an actual poster of the Nano Sun with the black dot of Venus against it. You can make your own poster with these dimensions. The diameter of the Sun should be 139.2 centimeters and Venus against it would be 4.1 centimeters. Place the stand in the field at a reasonable distance in line with the Nano Sun poster. Place the banner of the transit of Venus at one end and tie the marble on the stand like this. This is Nano Venus. Keeping the suspended marble and the black dot of Venus on the poster in line of vision, start moving back. You have to find a position from where the marble completely covers the black dot. It should merge with it. Where you now stand is the Earth. Everything is to scale, so start measuring. The distance between the poster and the suspended marble, the Nano Venus, needs to be measured first. It's 104 meters. Next, measure the distance of the Earth's position from the Sun's poster. This measures 149 meters. How do these figures compare with the real scale? Let's find the ratio of distance. When we divide 104 by 149, we get 0.69. Let's do the same with the real distances. Venus is 10 crore 70 lakh kilometers from the Sun and Earth at 15 crore kilometers. Let's divide the two. What we get is 0.71. That's the real scale, quite close to our calculation in the simulation. The hallmark of a scientist is curiosity. Compare the Nano Venus with the dot on the poster. Will they be the same in size? Why is the dot much larger? That's food for thought. Venus moves to its position of transit on 6 June 2012. Be prepared, for this is the only chance remaining in our lifetime. Write your responses to us at Surat Zameen Par, Vigyan Prasar, A50, Institutional Area, Sector 62, Noida 201309. You could even email us.